Hi everyone, my name is Genuario, and I'm so excited to share my capstone project with you titled Underwater Real Estate, Analyzing Policy Frameworks for Effective Eelgrass Restoration on the U.S. West Coast. For my project, I interned with NOAA Fisheries on the West Coast Mitigation Team, where I was mentored by my site supervisor, Annie Burney, and guided academically by my faculty advisor, Professor Francisca Santana. Eelgrass meadows are what I like to call underwater neighborhoods. These vibrant seagrass ecosystems provide prime ecological real estate. They support marine biodiversity, stabilize shorelines from erosion, and even help fight climate change by storing carbon. Here's an example of an eelgrass meadow right here. Globally, over 1 million people live within 100 kilometers of seagrass meadows. They play a crucial role in coastal economies and food security, especially through fisheries. But here's the problem. Despite their value, eelgrass meadows are rapidly disappearing. Human activities like dredging, pollution, and coastal development are taking a toll. Even though restoration efforts have ramped up, success remains elusive. A recent study by Beheshti and Ward in 2023 found that 30 to 65% of eelgrass restoration plots failed over the past 30 years. This raised a key question for me. My research question for my project was, how do eelgrass mitigation strategies vary across the West Coast, and what accounts for differences in restoration success? To further explore this question, I conducted qualitative research as part of my internship with NOAA's West Coast Mitigation Team. To conduct data, I interviewed NOAA specialists and reviewed scientific and policy literature to understand the barriers to effective restoration. Using a tool called atlas.ti, I used qualitative coding to analyze these expert interviews to identify patterns, insights, and themes. The result is a visual code map, shown in Figure 2 on my poster, that organizes the interview data into four key themes driving restoration outcomes. Three major insights emerged from my research. Number one, restoration success is region specific. There's what a NOAA expert called a latitudinal gradient of success. Southern states like California often do better than more northern ones. Why? A big reason is water clarity. Eelgrass needs sunlight to thrive, and in murkier, more urbanized waters in the north, turbidity blocks the light, harming growth, therefore contributing to less success in restoration projects. My second result that I found is that strong policy frameworks lead to better outcomes. When comparing statewide policies on eelgrass mitigation and restoration standards in Washington, Oregon, and California, I found that projects governed by structured policies, such as the California Eelgrass Mitigation Policy, had more consistent success. Take the San Diego Bay Mitigation Bank. Under the California Eelgrass Mitigation Policy, along with proactive planning, clear benchmarks, and accountability, this region not only restored eelgrass, but also boosted carbon storage benefits in the San Diego Bay. Number three, a lack of standardization is slowing progress. Currently, there's no unified monitoring system across the West Coast when it comes to eelgrass restoration. This makes it difficult to measure success or even really define what success in restoration looks like. In my interviews, NOAA staff members emphasized the need for a regional database and a community of practice where agencies could share data, track outcomes, and learn from one another. These findings reinforce what experts and recent studies have emphasized. Success in eelgrass restoration is achievable, but only when ecological realities, strong policy frameworks, and knowledge sharing work together in a coordinated way. So, why does all of this matter, and what does this mean moving forward? First, local conditions matter. You can't treat eelgrass like a one-size-fits-all problem. Differences in water clarity, sediment, light availability, temperature, and urbanization must shape regional restoration strategies across the West Coast. Secondly, policy matters. Structured mitigation frameworks like the California Eelgrass Mitigation Policy give practitioners a structured playbook. When there are clear rules and expectations, it's easier to plan for and measure restoration success. I implore other states to look towards this framework. Finally, we need shared monitoring tools, not just to evaluate results, but to continuously improve upon them. Figure 3 on my poster shows a framework called adaptive restoration. proposed by Beheshti and Ward. It encourages tailoring restoration projects to local conditions, tracking performance over time, and using that feedback to refine future projects. This practical roadmap is a call to action for agencies, scientists, and communities to look to moving forward. In conclusion, eelgrass meadows may be out of sight, but they shouldn't be out of mind. They're foundational to the health of our coastlines, supporting juvenile fish nursing and supporting biodiversity, as well as stabilizing coastal erosion. Beyond their ecological value for fisheries, eelgrass meadows are also powerful natural climate solutions. They can sequester carbon up to 5 times more efficiently than terrestrial forests and even buffer against ocean acidification, creating localized climate refuge. If we think of eelgrass as ecological real estate, we can make smarter investments through locally informed, policy-driven, and adaptive restoration. I'd like to thank my site supervisor, Annie Burney, my advisor, Professor Francisca Santana, and everyone who supported me, especially my cohort, my friends, and my family. Thank you so much for listening, and I'm happy to take any questions from here.